So today we're looking at Thinking with Math Models Investigation 2, Problem 2.1, and we're looking at linear models. Now, in some cases, linear models are nice and easy to figure out because the numbers go up by equal amounts. In other cases, like in this one, for the First State Bridge Painting Company, who bids on painting projects, they need to make a bid that's high enough that a company will make a reasonable profit. So the company looks at its records of previous projects and finds information about 4 bridges with similar designs that it had painted. And you see that table right here with the different bridges, the length of the bridge, and the cost of painting. So we use this information, and if we graph this information, we can kind of see where those would potentially make a linear model. So it's not a perfect linear model. You can see the dots don't line up exactly. It's a mathematical model, and it shows the approximate line or the approximate linear relationship between the bridge length and the painting costs. And so now the challenge mathematically would be, okay, it's not perfect, but it's close enough that we can describe it as a linear relationship, and we should be able to come up with an equation for that information. And normally we would just look at the graph and say, well, or the table, and say, well, it goes up by 100, 100, 100. So the change in, this would be our x, goes up by 100. But the problem here is that the change in y is not constant. And so we would have to find the average change here. This one goes up a certain amount, and this one goes up another. And so we would just average those, and we would take the average change in y divided by the average change in x to come up with our slope, and then use that to find a y-intercept. Now, we have this modern tool called a graphing calculator that will do a lot of that work for us. So I'm actually going to use that tool today to do the averaging work for us in this case. So what I've already done on my calculator is I've taken the information from the table that was given, and I put it in to lists. And there's a button on this particular calculator, which is TI-72, which says list. And I actually can put these numbers in these 2 lists just as they are seen, the 100, 200, 300, 400 foot length bridges, and then the cost of painting. And so I have those in my lists, and now the calculator will actually do the averaging of these from the 18 to the 37 to the 40,000 in this case, and will give me the linear equation I want in this case. So I'm going to go ahead and push some buttons here, the second and stat button. I'm going to go over to something called calculate, and then down to linear regression, ax plus b. And I'm going to hit that, and then I'm going to do it again. And it gives me this nice equation for my lists, and it says that y is equal to the a, which in this case is 155, plus the b, which is 3,500. So that's actually the equation for this data that fits that graph. So I'm going to write it down here. Y equals 155x plus 3,500. And you could kind of describe this in this way. If you're thinking about the bridge lengths, and as you increase the length of the bridge, this is really money, this is cost, and so is this, that the cost of painting a bridge is sort of a base amount, like $3,500, plus $155 per foot of bridge. This is a unit rate. And it's really the slope of the line. And it tells us something about the cost of painting bridges. In this case, if the x is the feet and the y is the cost, then it's $155 per foot to paint the bridge, plus again this $3,500 base v. So every time you write an equation, there's some meaning to every part of the equation. The y represents something, the x represents something. These other numbers mean things. Again, this is like a base cost. Regardless of how much bridge you paint, there's going to be some costs involved in painting that bridge. And so if we keep this equation in mind that we got from our calculator that did all the averaging work for us, and again we look over at the table, the graph, so you can kind of see where that $3,500, this is 0 and then this is 10,000, and so somewhere around here is going to be that $3,500, and then for every foot, and again we have some big jumps here so it's hard to see the actual $155 per foot, but that's what that's describing as we go up for the price of the bridge. So if you think about the questions that are asked, 2.1, the first question or the first thing that we're asked to do is to write an equation for a line that models the data, and that's what I did, again using the graphing calculator, letting it do the hard work of averaging for me. And so there's my y equals 155x plus 3,500 for question A1. So now I've got question A1 done. And I'm going to actually continue on to question 2, A and B, because now all I want to do is use the line or the equation to estimate the painting cost for similar bridges for different lengths. And so I could go up to the graph and look at 175 feet and estimate. So there's 150 feet, 175, and it looks like it's going to be somewhere around $30,000 to do that length of a bridge. But since we now have an equation, I can just bring the equation in. Say, so if we have 175 feet of bridge, let's just go ahead and use the equation to solve it. Y equals 155 times 175, that's the feet of the bridge, plus the 3,500. And I'm going to just let my calculator do the hard work for me here. So I have 155 times 175 plus 3,500, and it looks like it's $30,625, which is what I kind of estimated anyway. So now I have a little bit better answer. So it equals $30,625 to paint a bridge that's 175 feet long. So there was my amount for that. And so now that's the answer to question 2A. So now I've gotten that taken care of, or A2A. And then now, again, the next part says, well, what if it's 280 feet long? So again, I could look at the chart and go 280 feet is somewhere right around here. And that looks like it's going to be somewhere around $45,000 to $50,000 to paint that length of a bridge. But once again, I can get an exact, or at least a much closer value if I just use the equation. And if the bridge is 280 feet long, I'm just going to put those numbers right into my equation. Y equals 155, 280, that's the length of the bridge, plus the 3,500. And again, just put that right on into my calculator, just like I did before. Try to make it so you can see all this that I'm doing at the same time. Again, just using the calculator, putting in the numbers, 155 times 280 plus 3,500 and $46,900. $46,900. And again, that's right around what I estimated using the graph. And so my equation looks like it's working pretty well in terms of graphing and giving us answers that are right on that line. 46,900, and I remember I said it would be right around there in that particular area. Now there's a couple more questions. Question number 3A3 that we can answer again using the equation, because it says to use the line or the equation to estimate the length of bridges, similar bridges in which the painting costs are $10,000. This might be a spot where the graph is just really simple to use. So let's go up to the graph. If it's $10,000, and we just look at 10,000, there's 20, there's 0, there's 10. It looks like it's going to be right in there. That's only going to give us about, if that's 50 feet of bridge, about 25 feet of bridge length for $10,000. So if I were thinking $10,000, and again I can kind of work backwards in this case. If I got $10,000 and I want to know how much bridge, that's my feet that I'm looking for. If I work backwards, remember there's that $3,500, it's kind of upfront cost. If I take that away from the 10,000, then I'm left with $6,500 in painting costs, and it's $155 a foot. So if I divide by 155, the 6,500 divided by 155, and there's that 40, looks like about 42 feet of bridge is all I get painted for $10,000. And again, all I did was kind of work backwards, take away that $3,500 that you have to pay up front, and then divide by the $155 per foot. 6,500 divided by is the 42 feet of bridge. And then one more question in part A that we have to look at, and it's that if we had $60,000, so again I'm going to $60,000, and it's $155 a foot plus the $3,500. So I'm going to take that $3,500 away from the $60,000. Got to pay that cost right up front. And if I take the $3,500 from the $6,500, that's $56,500 in painting costs. And now I have to divide that by the $155 per foot, and I get about 365 feet of bridge painted for that price, for that amount of money. And we can go back to the graph. Is that 365 feet, $60,000 we started with. If I go back to the graph, $60,000, go over to here and down, you can see it's right where I estimated, 365, there's 350, 365 feet of bridge. So I could have gone to the graph and found about the same estimate, and it works. So our equation works, our graph works. These are different models. This model using the graph is helpful. This model using the equation is very helpful. They represent the same things, both very helpful ways of finding an equation and finding answers. And so that's just part A. We'll come back with part B here soon. You can check out that on the next video.